Oh, no, that's not parallel. Because it would be like this, right? We'll just have it on that, so it feels on. Because they have the paper next to them.
Oh, true.
Just turn it on just for the slope. Wait, scroll to the slope. I mean,
no, I'll turn it on. No, you gotta scroll through as per normal. I'll control the projector. Okay, let's go.
Right.
Intro first.
Let me know if the audio is not working. Right, hello. We are math tutors involved with the Zhang's math course, and we'd like you to know that all the courses are marked down by 50% in term 1, so this term. Also, there is a 2-week trial, which is free for existing Zhang students, or otherwise $80 for all other students. The setup that we'll be using today is very similar to the online lesson format at Zhang's. So I'm Kevin, and I wrote the Extension 2 course for Zhang's. I'll be going through part of the paper. I'm also joined by 2 other tutors who will introduce themselves accordingly. Sorry? Oh, okay. All right. So, Extension 2 and Extension 1 are quite similar in a sense, right? It's true that Extension 2 has different content from Extension 1, but the same sort of general thinking applies. So, whether you're interested in doing Extension 2 or Extension 1, I highly recommend you check out the Zhang's courses. As we go through the questions today, you'll realize that we'll be going through a lot of the general ways of approaching these questions. Like, how do you figure out how to get these answers? What are the key words or like the key indicators in each question that suggest to you that this may be the correct methodology? So yeah, if you're interested in any of those, please consider Zhang's. So, I did Extension 1 HSC in 2021, and then I did the Extension 2 in 2022. So it has been a while, but fortunately I still remember all of the key elements. So in Extension 1, I got 100 overall as an accelerated student, and in Extension 2, I state ranked first in the state. So hopefully you consider me suitably qualified to go through this exam. We're beginning with question 14, the best stuff first. So question 14a asks us to find the domain and range of this function, the solution to the differential equation. Whoops. So what we should notice first is that this is a separable differential equation, as they should basically all be in the syllabus, which means that we can just approach it in a very generic sort of format, like this. And so that gives us negative e to the negative y equals e to the x plus c. So then we can sub in our initial conditions. And then that gives us our overall function. Negative e to the negative y equals to e to the x minus 2, or e to the negative y equals to 2 minus e to the x. So we can turn this function into a format in terms of y. If we do that, we get y equals to negative ln of 2 minus e to the x. And so just looking at this function here, and also e to the minus y equals 2 minus e to the x, what we should see is that 2 minus e to the x needs to be greater than 2. Since we're trying to find the domain and range of the function, right, we look at this formula and see, and I always recommend you start by looking at the domain and then see how you can link that to the range. So, looking at the domain of this function, right, ln, the inside of ln is always greater than 0. And also, e to the minus y is always greater than 0. So, we know, therefore, that 2 minus e to the x must be greater than 0. And this tells us 2 is greater than e to the x, and therefore x is less than ln 2. We can make this assumption because we know that the diff of e to the x equals to e to the x, which is greater than 0 for all x. And so therefore we know that this is a monotonically increasing function. Which means that we can just kind of like, we know that if e to the x is less than 2, then x is less than ln 2. We can just make that assumption. So that becomes part of our domain. Then we can link that domain to our range. So we also know that 2 minus e to the x is going to be less than 2, right? And that's because e to the x is greater than 0. And so that means that ln of 2 minus e to the x has to be less than ln 2, which means that negative ln of 2 minus e to the x has to be greater than negative ln of 2, which means that y must be greater than negative ln of 2. And that's the second constraint that we have for this function. So then the last thing I like to do is to make sure that none of these constraints interfere with each other or any of the properties of the function itself. So looking at this here first, right? We know that x must be less than ln 2. So that means that e to the x can't be bigger than 2, otherwise this thing on the inside would be negative. So that doesn't seem to really interfere with our y value, because what we know is we have our ln values, they have to be, inside has to be greater than 0. So if we look at the ln function, we know that it asymptotes towards negative infinity, and it passes through 1 here. So the negative ln is going to be like that, flipped, right? So if the inside of our function needs to be greater than 0, that doesn't really interfere at all. We know that our function can approach infinity. Second, let's look at our y constraint. We know that y must be greater than negative ln 2. So where does that come from? Again, because 2 minus e to the x must be less than 2, which means that y must be less than, y must be greater than negative ln 2. So basically, our function looks like this line here. And so therefore, we have our answer. Y is greater than negative ln of 2, and x is less than ln of 2. But also, looking at this graph here, right, because we've graphed it out, we also see that x can't be any of these values, here. So, yeah. So that means our actual constraint. Oh, sorry, no. No, never mind, because this graph I've drawn has e to the x here. Yeah. So in other words, we don't need to worry about it. Our constraints are just x is less than ln 2, and y is greater than negative ln of 2. All right, nice. So, moving on to part B. So moving on to part B, right, which is in my opinion probably one of, if not the hardest question in question 14. We're asked for what values of the constant k would the function have an inverse. So what we should notice here, right, is that this f of x value is actually quite complicated. So there's kind of like two ways that I would approach this. The first way would be to find the inverse function. But looking at this, I don't think I can find the inverse function. It looks really messy, and if you sub it in, just to quickly show you, you'd end up with x equals to ky over 1 plus y squared plus tan inverse of y, and that looks like an absolute mess, so I wouldn't do that. So that option is now off the table. What can we do instead? Well, the other thing we need to know about inverses, right, is the whole point of an inverse is that it must pass the horizontal line test. So if we had a function, right, like this, it passes the horizontal line test, that's great. If we have a function like this, it doesn't pass the horizontal line test. So what is the distinguishing factor between these two cases? It's that turning point here. And that's the key to part B. We need to show that there aren't any turning points. That's what decides if our function has an inverse or not in this case. There's a few things that are worth noting about this graph. They're not necessary for the question, but it can help you visualize things a bit better. The first thing is that this is an odd function. And the second thing is that it passes through the origin, so at 0, 0. And so hopefully that gives you a rough idea of what this function would look like. We'd expect something, maybe something like this. Either way, it needs to be symmetrical about that. It needs to have some level of rotational symmetry because it's an odd function. So we're looking at something like this, roughly. When we differentiate f dash x, that becomes v u dash minus u v dash over 1 plus x squared all squared. And you also have to add the tan inverse. So the diff of tan inverse is 1 plus x squared. Sorry, 1 over 1 plus x squared. Okay, so if we make a common denominator using those values, first of all we have this, which is from the first fraction. And we also get 1 plus x squared on the second fraction. And so that gives us k plus 1 plus 1 minus k of x squared. And now to find stationary points, we're going to let this be 0. Doing so gets us k plus 1 plus 1 minus k of x squared equals 0, because we know that 1 plus x squared all squared can never be 0. So this, the numerator, has to be 0, which means that x squared must equal to k plus 1 over k minus 1. So that is what x squared equals to. Now, this is if we wanted to find a turning point. But like I mentioned in the beginning, the goal of this question is to make sure that we don't have a turning point. So we want no turning point. And how do we get no turning point in a case like this? Well, we should know that x squared can equal any number as long as it's positive or 0. So that means that if we don't want a turning point, we need k plus 1 over k minus 1 to be less than 0. And so the way you solve that is, of course, multiply each side by k minus 1 all squared, because if you multiplied it just by k minus 1, you could potentially flip the inequality by accident. So if you multiply both sides by k minus 1 all squared, you get this, which is a very nice and simple quadratic inequality. Now, if you know it already, then that's great. But if you don't, then just sketch it out here. And we're looking for this area in the middle. In other words, 1 is less than k, sorry, negative 1 is less than k, is less than 1. And those are the range of values you can get for this function. If you're like, obviously you can't do this in the HSC, but after you do these sorts of questions, which are really complicated, I always recommend you have a look at the graph yourself. So maybe go into Decimals or something, play around with the k values, and you can see how your answer is actually like interacting with the function itself. All right. Alright, so part C. We start off with a very quick question. Explain why the solution only has, why the equation has exactly one solution. So you might look at this for a moment and think for a bit. And the answer really, and this is, again, there's many different ways, I guess, to look at this situation. But the way I want you to think about this one is more graphically. So if you think about the functions tan inverse of 3x and tan inverse of 10x for a moment, right? All tan inverse functions, they kind of just, they look very similar. They're all between pi on 2, negative pi on 2, and they all have this sort of shape. So although these functions won't look like exactly the same, when you add them together, you'd expect it to look something like this. Very roughly, again, just speaking. So that's negative pi, and that's pi, okay? So that's what the function itself roughly looks like, tan inverse of 3x plus tan inverse of 10x. And you're trying to find the solution. One of the key things to note about finding the solution, right, is you're actually intersecting the function with a horizontal line. So if we look at the horizontal line, y equals to theta, which is between negative pi and pi, what we'll notice is the reason why there's always one solution only is because the function is monotonically increasing. So in the actual test, you don't write all of this will take forever, but you're just thinking this in your head, maybe you're drawing this on your scrap paper, and then how do we show it? Well, we're just going to let f of x be equal to tan inverse of 3x plus tan inverse of 10x. Then just differentiate it. And just note that this is always going to be greater than 0.
100x.
Yep, it's 100x squared. Whoops. So, always going to be greater than 0. And so, therefore, we're only going to get one intersection, right? That's the idea behind this. So, in part 2, we now need to solve this function. Now, normally the way you kind of try to solve these is you tan both sides. And the reason you do that is because then you can cancel out the tan inverses. Oops. But of course, the limitation with this method is you actually can get multiple solutions, so you have to be very careful as to like which solutions you're choosing. But since in part 1 you proved that there was only one solution, you can kind of just do this without worrying because you know you can only get one possible solution of x. Either way, this is just compound angle, which you should be familiar with at this point. And tan of 3 pi is just -1. So if you expand it all out, you get 13x over 1 minus 30x squared equals to -1. So 13x equals to 30x squared minus 1, and that's just the quadratic. Oh, it actually had solutions. I probably should have tried guessing the solutions instead, but whatever, it is too late now. So the answers are 15 and -2, I believe.
Yeah.
Okay, great. So those are your solutions, but again, the trick, right? Always at the very end, once you have your solutions, just take a step back, don't move on, think, are those solutions actually like legit solutions? So we know there's only one possible answer. That was like the whole point. So the way we can ascertain as to like which answer is which is we can just sub it in, right? That's literally the easiest way of doing it. You could try some other like explanation, but why would you when it's so much easier if you just try to put the numbers in? So if we...
It's over 2a. Is it over
Oh,
2
whoops, sorry.
Yeah.
I feel like I made a mistake like this very recently. Okay, so you get 30 over 60. Yeah, and -4 over 60, which is equal to half or -1 over 15. Nice. So, yeah, then you try sub those in and see what happens for each of them. Or you can actually just do a little bit of reasoning if you wanted to. Because just looking at, actually no, we'll just try subbing it in, I guess. So let's start with half, right? And we actually don't even need to sub it into the calculator. We could, that works perfectly. But I'll just like reason it with you here. So if we sub in half, right, our expression becomes tan inverse of 1.5 plus tan inverse of 5. Those two seem like it would be okay. Let's try -1 over 15. So we get tan inverse of -1 over 5 plus tan inverse of -2 over 3. And so what you should know about tan inverse of like a negative number is that it should give you a negative number. So therefore, it couldn't possibly be 3 pi on 4. So your only option is half. And again, you can just do that by chucking it in your calculator and seeing what happens. That would be just as good and probably, again, save you from making silly errors. So just take the simplest option where possible. Right, so part D will be brought to you by another one of our esteemed tutors who you'd like to invite on the stage.
Hello, my name is Jim. I teach Year 10 Mathematics Tuesday at Strathfield. And I'm going to be going through the very last question of the exam. So question 14D, they give us a projectile. So this is a pretty standard projectile. So we should be familiar with these equations already. So Vt cosine theta, Vt sine theta, minus Gt squared over 2. And they give us the distance function, right? So the distance would just be the magnitude of this vector. All right, and then we're asked to prove this inequality, which is that theta is less than sine inverse of square root 8 over 9. Okay. So looking at this, I don't really know how to get here, but where we can start is by looking at this, right? This is what they're given us, so I'm going to find the magnitude of r, which is simply the x component squared plus the y component squared, just by Pythagoras. So it's going to be vt cosine theta squared plus vt sine theta minus gt squared over 2 all squared, and that's in a square root. Alright. So expanding this out, we get v squared t squared cosine squared theta plus v squared t squared sine squared theta minus 2vt sine theta gt squared over 2 plus g squared t squared over 4. Okay. Oh, sorry, yeah, to the power of 4. So this looks like a really big mess, but I can see here that this is just what's it called? Sine squared theta plus cosine squared theta plus sine squared theta. So if we were to factor out this v squared t squared here, it would just be 1. So this is v squared t squared. This right here, the 2's are going to cancel out. So we're going to get vt cubed, and then there's a g here, and then sine theta. Oh, sorry, it is a minus. And then plus g squared, t to the 4 over 4. All right, so this is our distance function. And from here, we have the condition that this distance is increasing for all t greater than 0. So this is increasing. And that immediately tells me to look at the derivative. Okay, so I'm going to define f of t to be whatever's in the square root. Okay, and I'm not going to define f of t to be square root of whatever this is, because the square root is going to make everything more complicated. We can just notice that if this function is increasing, then the square root of this function will also be increasing. So I'm just going to choose whatever's in the square root here. So v squared t squared minus g v t cubed sine theta plus g t to the 4, g squared t to the 4 over 4. Okay. I didn't miss anything. And then we want f of t, which is going to be 2v squared t minus 3vg sine theta plus yes, t squared, g squared t to the 3. And we want this to be greater than 0. Okay, so we can do a bit of simplifying here. We can notice that there's t's everywhere here. So I'm just going to divide by the t. So 2v squared minus 3 v t g sine theta plus g squared t squared. And then the inequality is not gonna change at all, because t is time, and time has to be greater than 0. So we don't have to worry about dividing by it. Yeah. Okay, so let's think about what this means graphically. So this is a parabola. And when a parabola is greater than 0, strictly greater than 0, what that means is it doesn't intercept the x-axis at all. Or here it will be the t-axis. So that means that this parabola is going to have no solutions. This equation, if this was equal to 0, this is going to have no solutions whatsoever. And what that means is the discriminant, right, so that's b squared minus 4ac. This has to be negative. This has to be less than 0. And then that's the link That's how we can isolate this sine theta. Okay, that's how we can isolate this sine theta. Because the discriminant is going to be b squared, so we're going to have this sine theta on its own. So it's going to be 3vg sine theta squared minus 4 times AC, so 2v squared, and g squared. All right. And then we have the condition that this has to be less than 0 in order for this to not intercept the x-axis. So by just expanding that, we get 9v squared g squared sine squared theta minus 8g squared v squared is less than 0. Putting this to the other side, we get 9v squared g squared sine theta is less than 8g squared v squared. Sorry, there's a square here. And I'm running out of space, so I'm just going to skip a couple of steps. I'm going to put this over here. So 9g squared v squared. And yeah, this is really nice. So we get sine squared theta is less than 8 over 9. And then therefore sine theta is less than plus minus square root 8 over 9. Sorry. All right, so sine theta has to be between these two values, yeah. And then just taking the sine inverse, we've proven it. Okay. All right, so I'm going to move on to question 13 now. Okay, so for question 13, we're given a slope field. That is the slope field for this differential equation. And we're just trying to get the projector working, so we'll display.
2000.
There we go. Oh, sorry, that's 2000. So part 1 says, explain why the the solution that passes through the point S can also pass through the point T. So visually, this is kind of obvious, like there's a line here. And we just have to interpret what this line means. This line here is going to be an asymptote, because when we solve this differential equation here, we should expect some sort of exponential. And this exponential is going to asymptotically approach this. And since it's asymptotically approaching this, it's like a boundary that you can never really cross. So this solutions down here cannot cross into here because of this asymptote. They're just going to keep approaching this. Okay. So they're never going to meet each other. So therefore, a solution cannot pass through S and T at the same time. Okay. And then I already did part 2. I already sketched the point that passed through the curve that passed through the point S. Is just like, it's pretty easy, just drawing. And then number 3. Find the predicted value of the population at which the rate of growth of the population is the largest. So rate of growth of P, and we want to find when this is the largest. So in other words, the rate of P, that's just dP on dt. And we want to somehow like maximize this. And we're already given the equation of this. What? Okay. So we're already given the equation of this, And to maximize this, well, we just have to find the derivative of dp on dt. So we have to find d squared p over dt squared. That's going to be so 2000 minus 2p. And then to maximize this, we want to find the stationary point. So we want to make this equal to 0. And then we can easily see that p will have to equal 1000. Right? And then this cannot be a sort of minimum because we can just see from here it's always increasing. So it can't be a, so this has to be a maximum. All right. Let's move on to B. Can you turn the projector on? All right, so B part 1 asks us to prove this identity. So sine to the 4x plus cosine to the 4x equals to 1 plus cosine squared of 2x over 2. All right, so I could either start here or I can start here. But I'm going to choose to start over here because it's easier to simplify something that's hard than to make something that's easy look more complicated. So this is all in terms of cosine. So what that tells me to do is convert this sine to the 4 into 1 minus cosine squared x, all squared, plus cosine to the 4x. All right, and then when we expand this, it's going to be 1 minus 2 cosine squared x plus cosine 4x plus cosine 4x. This is 1 minus 2 cosine square x plus 2 cosine 4x. All right, so that's 1 minus.
You can expand on the side. Hold on.
All right,
You can expand from the other side.
can I make this into this? Or do I have to
Yeah.
expand?
You can put it over 2 first to make it look the same. And then.
Okay, I'm just going to go from
Oh,
here.
you can. Yeah, you can.
See, I think
Think
I
it's
would
easier.
have gone from sine squared x plus cos squared x all squared equals to 1.
Yeah.
Because then I can convert that into sine 2x and then change that into 1 plus cos squared. No, 1 plus cos squared is cos squared.
I'll just do this and
I
then
think you can
hopefully.
just expand from the other
Yeah,
side.
hopefully if I expand this, it will equal this. So,
Yeah,
1
sure.
plus.
So you would use the cos 2x expansion to cos squared x, 2 cos squared x minus 1.
Okay, so this is 2,
Yeah.
2 cos squared x plus 1 squared over 2. And then, yeah, that should equal that.
Yeah. Because you want it all in terms of cos.
So 4 cos squared x minus 4 cos, sorry, that's to the 4 squared x plus 1 over 2. Okay, and then we can see that this 1 and this 1 are going to combine to form a 2. I'm just going to reorganize everything. That's going to be a minus 4 cos squared x plus 4 cos 4x over 2. And we can see these are identical. Okay. All right, so hence or otherwise evaluate integral from 0 to power 4.
There's a comment for you.
It's a comment. Can you change cos 4x into 1/2 plus 1/2 cos squared x squared? Yes, you can. Okay. Hang on, let me see it again. Cos 2x. Oh, no. Oh yeah, thank you. Yeah. So that would be the quickest way to do this. Yeah. All right, so this integral is pretty straightforward. They asked us to prove an identity in the first part, and then now we just have to evaluate this integral. And it's the exact same thing that they gave us in part 1. So I'm just going to replace it with whatever we got there. So. Oh, sorry, pi on 4. Okay.
We'll do the MCQ at the end. We're going backwards.
So I'm going to separate this into two integrals because we know how to do this integral and we know how to do this integral. So it's going to be integral from 0 to pi on 4 of dx over 2 plus 1/2. And then I'm just going to simplify this straight away. We should already know this identity by now. So that's a quarter integral from 0 to pi on 4 of 1 plus cosine 4x dx. Yeah. And then that's x over 2 plus 1/4 x plus 1/4 sine 4x evaluated from 0 to pi on 4. Okay. When we plug in pi on 4, we're going to get here is pi over 8. Okay, so this here is going to become pi over 8 plus 1/4 pi over 4. And then this is going to vanish because sine 4 times pi on 4 is sine of pi, and sine of pi is 0, so that's plus 0. Minus, and then when we plug in 0, everything here is just going to disappear, so it's just 0 again. All right, so it's going to be pi over 8, which I'm going to write as 2 pi over 16, plus 1 over 4 times pi over 4, which is pi over 16, so we get 3 pi over 16 as our answer. Okay. All right, number C. I think this is the hardest one in question 13. You just have to think a little bit creatively. So we have a vector A as being 1, 3. We have a vector B as 2, -1. The projection of vector, some vector x, we don't know what x is, but some vector x projected onto A. So I'm going to define x, right? They're asking us to solve for this vector. So I'm just going to make this a variable. Okay, so this vector is my variable, is what I'm solving for. And then the projection of vector x onto the vector A, they give us as k times A. And similarly, the projection of the vector vector x onto B, that's p times b. All right, so just by using the projection formula, we can find k and p in terms of x and a. So this would mean that x dot a over the magnitude of a squared times a is equal to k times a, which would mean that we can just get rid of these. Right, so if this equals this times a is k times a, then we can just equate coefficients and get that x dot a over the magnitude of a squared is k. And then similarly, x dot b over b squared times b should equal to pb. And then again, we can just equate coefficients and get rid of the vectors. Okay. So we know what a and b are, so I'm just going to evaluate these two. This is going to be 1, 3 dot xy. So over the magnitude of 1, 3, so 1 squared plus 3 squared. This is what? 2 negative 1 dot xy over 2 squared plus 1 squared. Okay, so we have 3x. Actually, let me rearrange this. I'll make this nice and pretty. So x plus 3y is equal to, so that's just 10 there. So I'm going to multiply the 10 over here. I'm just going to get 10k. And then this dot product is 2x minus y. This 2 squared plus 1 squared is 5. I'm going to multiply that over here, and that's equal to 5p. And we have a system of 2 linear equations. Okay, so we have 2 variables, so we have 2 equations. All we have to do is just solve for x and y, respectively, and we'll be good. So I'm going to call this equation 1. I'm going to call this equation 2. All right, I'm going to solve for y first. So I'm going to use elimination, because I think that's much easier. So I'm going to have 3 times equation number 2 plus equation number 1, so that I can get rid of the y's. So 3 times equation 2 is going to be 6x minus 3y. Equation 1 is x plus 3y. 2 times 5p is 15p, and then 10k. And this gives us that 7x, right? So 6 plus x, that's 7x. I'm going to divide the 7 over. So x is going to be 15p plus 10k over 7. All right, so that's our x component. Now we just need to do the same thing to find y. Sorry. Oh, I said I was solving for y, but I actually found x. Okay. Anyways, we just need to eliminate the x now to find y. So I'm going to have, again, equation 2. I'm going to subtract 2 times equation 1. Okay, so equation 2 is 2 times x minus y. And then 2 times this is 2x minus 6y. And that's going to be equal to 5p minus 20k. Okay, so the x's are going to vanish, and then we're going to have 7y equal to, and I'm just going to multiply this negative across. So I'm going to get rid of the negative, and then this is going to flip. So it's going to be 20k minus 5p. So y is 20k minus 5p over 7. Okay, so therefore our vector x is equal to 1 over 7 times 15 plus 10k, sorry, 15p plus 10k, and then y is 20 minus 5p. 20k minus 5p. You could also factor out a 5, so 5 on 7. 3p plus 2k, 4k minus p. That's our final answer. Okay. Are there any questions?
No.
Okay. All right, final question for 13. So part D. All right, so they give us this integral of e to the 3x minus e to the x of 4 plus 8 e to the 2x plus e to the 4x dx. And they want us to use the following substitution. So u equals to d e to the x minus, plus 2 e to the negative x. All right. And then we're given a hint here as to consider u squared, which I'm going to keep in mind. All right, so I'm just going to find du. Okay, so du is going to be e to the x minus 2e to the negative x times dx.
Now you should consider u squared, like square root.
Just find u squared.
Just find u squared.
Okay. I'm going to find u squared. I'm gonna use the hint that they gave us, because this is not really working out right here. We can't really make this into that. So we have e to the 2x plus e to the negative 2x plus 2. Okay, so that's almost the denominator. Actually, no, it's not.
It is. It looks very similar to the bottom, but it's off by a factor of
What is it off by a factor of?
e to the 2x.
Oh, right.
So you can see negative powers in your diff and your u squared that it told you to consider, but clearly in your integral you don't see any negative exponentials. So you want to make it negative, so you can divide top and bottom by e to the 2x.
Thank you, Vivian. Alright, so I'm going to multiply top and bottom by e to the negative 2x. Because this 4x here I don't like, right? We have only powers of either 1 or 2. I don't like this power over here. I also don't like the 3 here. And then the 2 is the number that subtracts them to get either 1 or 2. Right. So over here, by distributing, we're going to get e to the x minus e to the negative x.
There's a 2 in the numerator.
Oh, there was a 2 here. Okay.
Yeah. And that looks very familiar.
Alright, and then here's me e to the negative 2x minus 8 plus e to the 2x.
Plus
Yeah, plus a.
Plus
The minus should be a plus.
A.
Did I actually just copy the whole thing down? Huh?
Yeah.
That's why I was getting confused.
Yeah.
Okay.
2x.
Okay, this is much nicer now.
2x, 4x on the denominator.
Oh my god, okay.
Friend's handwriting.
Yeah. Handwriting.
Okay, this is a lot nicer now. This u sub is just that, so that's just du.
It's plus 4 there.
And then u squared is this plus 4.
Then
Okay.
plus 4e to the minus 2x.
Yeah, it's plus 4 e to the minus 2x. And in the middle is a plus 4. Oh yeah, you can say that too.
Alright, so u squared is this. They told us to consider u squared.
And the denominator.
I want to make this into something like that, basically. Alright, so I don't see a 4 here, so I'm going to force there to be a 4. I'm going to get rid of the a, because a is 4 plus 4, right? I'm going to write this as 4 plus that. Okay, and now that's exactly u squared. So that's 4e to the negative 2x plus 4 plus e to the 2x. Okay. So that's u squared plus 4. And that's quite easy now. That's just inverse tan integral. So 1/2 tan inverse u over 4 plus c. Oh, that's not 4, that's 2. And we get 1/2 tan inverse e to the x plus 2e to the negative x plus c. Alright.
Great.
Now, another one of our experienced, charismatic, and charming maths teachers is going to come up and do question 12. Thank you very much.
Okay. Thanks. why are you writing so high up on the board? Maybe you should have rubbed it out before I did it.
I'll be the Bible for you.
Okay. So hi everyone. I'm Vivian and I'm a maths teacher at Zhang's as well. I teach a year 11 2-unit class. And yeah, so I'll be going through question 12. So it's a pretty simple question compared to what everyone else has gone through. So for 12a, we're given two vectors and we're told that these vectors are perpendicular. So with perpendicular vectors, what we can say is that their dot product is going to equal to 0 because they're perpendicular. And if you're perpendicular, the angle between the two vectors is 90 degrees. And if we look at the other formula of a dot product, we know that cos 90 would give us 0. So dot product, multiply the same components. So a cubed plus 5a squared plus 2a minus 8 is equal to 0. This is a cubic polynomial. So the kind of only way we can go about solving this would be to kind of guess the first factor. So we can see how there's the coefficients are 1, 5, 2, and then a negative 8. So you can see that a is equal to 1 is a factor because 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8 is equal to 0. Therefore, we can say a minus 1 is a factor. And then you can go about other ways, but the fastest way I can think of is just to use long division, divide out the a minus 1, and we will be left with a quadratic, which we can solve. So doing long division, quite simple. And we should get a remainder of 0 because we know it is a factor. Yep, so we're left with 8a minus 8. So that is indeed a factor. And so we can simplify this polynomial into a minus 1 times a squared plus 6a plus 8. And it's equal to 0. So to solve for a, this quadratic is easily factorized into a plus 2 times a plus 4 equals to 0. Therefore, we can say a is equal to 1, negative 2, and negative 4. So 3 solutions to a. So that's 12a. Looking at 12b, we've got a region, and we are finding the volume it creates when it is rotated about the x-axis. So again, quite simple. We just need to, rub the board out first. So it's a pretty simple curve. So it's just y equals to x cubed. So we can easily just draw this out to have a geometric kind of visualization of what's going on. So we just draw the y is equal to x cubed curve from 1 to 2. So it's this region, R. And we're rotating about the x-axis. So what it will look like is something like this. Hopefully that's, yeah. So this is the volume of the solid. And essentially the integral we're trying to find is going to be pi. So don't forget the pi when you find volume from 1 to 2 of x cubed all squared. So the function squared with respect to x. And so this is just the integral of x to the 6 from 1 to 2. So using power rule, 2 to the 7 minus 1 over 7 will get you 2 to the 7 is 1 to 8. So 1 to 7 pi over 7. And yeah, quite simple. So we've got Kevin back on explaining 12c.
Microphone, by the way.
Yes.
Hello, I am back for the stats. Okay. So
if you guys want the last question, you can go back in the live video to watch it.
Yep. So for question 12C, I think the key giveaway here, like even before you think about the question, is that they've told you that they want you to use the standard normal distribution, right? So if you think about everything that you've learned in extension 1, the only topic which really requires that standard normal distribution is going to be normal approximation. And we know this because there is a fixed probability of each of each person the charity worker talks to. There is a fixed probability, 0.31, that they donate. And so that's characterized by a binomial distribution. So to show good working out, we want to let x be the number of people they talk to. Sorry, the number of people who donate. And then x belongs to this binomial distribution with 100 people and a 0.31 probability. Then we're going to let our sample proportion be x over n. We can find the expected value of the sample proportion and also the variance. And then we can say, let this sample proportion belong to the normal distribution with the mean and variance, approximately. So, we want to find the probability that at least 35% of people talk to made a donation. So we want to find the probability that the proportion of people is at least, so greater than or equal to, at least 35%, or 0.35 in this case. So, now, that's going to be equal to the probability that, 1 minus the probability that the sample proportion is less than 0.35. And just note that for all continuous probability distributions, it doesn't matter whether you have equals to or not equals to, because the probability that x equals to something, like let's just say 0.1, is 0, right? So that's just the case for all continuous probabilities. Anyway, we're trying to find this. So we need to relate it back to z. And to do that, we have the score, x, minus the mean over the standard deviation. So let me just calculate that. All right, and that should give you an answer of 0.864877. And of course, then we need to think about how we round this number. So we need z to be less than this number. If we look at the table at the very end, right, we see that there's many different values that, there's like 2 different values that z could be, either 0.86 or 0.87. So z has to be less than this number, which means ideally we should be using z less than 0.86. And also, if we round this number, it also equals 0.86. So it's a good number to use on the table. So that equals to 1 minus, and then we just look at the table, find that value. 0.86 is 0.8051. I'm just going to check that. Yep. So if we do that subtraction, we get 0.1949 as our answer, or in other words, a 19.49% chance of this happening.
Okay, you can rub it out.
Mm-hmm. And now back to Vivian for the rest.
Thank you. Okay, so I'm back for the math induction question. So standard math induction divisibility. So step 1, we want to prove that it is true for the first value. So n is equal to 1. So we can say that 2 to the 3n plus 13, so it's 2 to the 3, which is 8, plus 13 is 21, and this is equal to 3 times 7. Therefore, it's divisible by 7, by a factor of 3, and therefore true for n is equal to 1. And we start our induction step, so we want to assume it is true for n is equal to k, where k is a positive integer, so starting from 1 as well. And what this means is we want to say that 2 to the 3k plus 13 is a multiple of 7, so 7m's. We can denote m as any integer, or positive integer if you wanted to say that. And this is equation 1. And then we want to use this to prove true for the case where n is equal to k plus 1. Again, k plus 1 would be a positive integer because k is 1. So it's 3k plus 3 plus 13 is equal to 7n, where n is another positive or just integer. So we can start from the left-hand side of equation 2 and say that this is equal to 2 to the 3. So take out that separable part of the power plus 13. This is equal to 8 times 2 to the 3k plus 13 minus 13. So we want to do this step so that we can kind of directly sub equation 1 into this. So this is equal to 8 times 7m minus 13 plus 13. I'm going to skip a step here and just say this is equal to 7 times 8m minus 13, and therefore it's equal to 7n, where we can say where n is equal to 8m minus 13, which must be an integer because m is an integer. And integers are, we can plus and subtract them. So this is equal to the right-hand side of equation 2. And then you kind of move on to writing a little paragraph for step 3, which is the kind of conclusion. So you can say that because it is true for n is equal to 1, as I proved in step 1, and it is true for n equals to k plus 1 if true for n is equal to k. Which is step 2. Therefore, it is true for n is equal to 1 plus 1, because if it's true for 1, it must be true for the next, which is 2, and it must be true for 3, ... and so on. And then, by the principle of mathematical induction, okay, a bit tedious to write, but by the principle of mathematical induction, it is true for n is greater than 1, and n is an integer. Great, so that's 12D. So moving on to 12E. 12E is, again, quite simple, just a graph, and we want to find the boundary or the range of x such that this inequality holds. So okay, let me scroll down. Okay, so the first way we can kind of do this question to just check your answer is really just to draw the curve, because they already gave you that diagram on your test paper, so you can kind of just draw it on the book and take a look at what your answer is going to look like. So x over 6, so this is the function y is equal to 1 over absolute of x minus 5, so it's just a hyperbola and we just flipped it. So we can draw the line y is equal to x on 6, because that's going to just pass to the origin and look something like this. Not the best to scale, but that's that. And if you just look at the diagram, we want x on 6 to be greater than the curve. So it's only this region where the line is on top of the curve. So we kind of just need to find that intersection point. Am I right? Yeah. Okay. Okay, so from the graph, we can see that we just need to find that intersection point. And this is the intersection point between the line and the positive branch, so the right-hand side branch of this hyperbola. So that is just going to be the branch where x is minus 5 is greater than 0. So we want to find the intersection between x on 6 and 1 on x minus 5. So you can equate them. X squared minus 5x is equal to 6. X squared minus 5x minus 6 is equal to 0. X minus 6, x plus 1 is equal to 0. So x is equal to 6 or negative 1. So clearly, this number here is 5. So it's to the right of 5. So it must be 6. So this is 6. So we can see that from the graph and our calculations that for x on 6 to be greater than or equal to 1 over absolute of x minus 5, x needs to be greater than 6 or equal to 6. Right.
This region here. I don't know how there's a region there, but I don't think Desmos is glitched.
Okay, so
I think that's fine. Yeah.
I think you can check the other half. You can check the other half of the region when x minus 5 is negative. I checked that before, and you should get no solutions, as you can see from the graph. So, our fellow teachers will give me a solution.
Okay, so basically we looked at it on Desmos, and there's another mysterious region that somehow appeared. So just trying to figure that out.
Yeah, so I believe because if we do check for the negative region where x minus 5 is less than 0, then we're equating x on 6 to negative 1 over x minus 5, which should just get you negative x squared plus 5x is equal to 6. X squared minus 5x plus 6 is equal to 0. X minus 3 times x minus 2 is equal to 0. So x is equal to 2 or 3. So the parabola would look something like this.
Yeah, I think that solution does exist.
Maybe square the whole
I think it's between 2 and 3, right?
Yeah. If you maybe square the whole thing, that gets rid of the absolute value.
Wait, it's between 2 and 3.
So the reason why is because it's not x over 6.
Give him the mic.
Oh, okay.
You can
So yeah, the reason behind that extra solution, I think it's because while you could try to solve x on 6 is greater than or equal to 1 on x minus 5, and if you just that's correct for this one. If you try to solve the other region, you get x on 6 is greater than or equal to 1 minus 5 minus x, 1 on 5 minus x. That's what you might think. But actually, because it's an absolute value, you have to solve less than or equal to 5 minus x as a region, right? So that's the reason why we missed the solution in our working.
Yeah.
So,
You can continue.
oh,
on
okay,
that.
sure.
I'm sorry, guys.
All good, all good. So, since we know that x is less than 5 in this case, right, that's a negative number. So, when you flip it over, you have to make sure you flip the sign again, right, which is what's so deceptive about this. When I was quickly doing it, I made that mistake. 5 minus x is negative, so you move it over, you have to flip the sign, then you just get x squared minus 5x minus 6 is greater than or equal to 0.
Yeah. No,
Oh.
less than 0.
Oh, wait a second.
Wait a second.
No, sorry, negative. I missed the negative. Yep, so, okay, so then you get, you get x squared minus 5x plus 6 is less than or equal to 0.
Yeah.
Yep, and then you get this, and so you get this.
Yeah.
2 less
those
than
are
equal to
the
x
two
less than equal to 3.
reasons,
Yeah. And quick tip for testing this, by the way, sub in 2, sub in 3, they should be equal, then sub in 2.5. And if the inequality holds, then it's highly likely that this is also a correct solution, which it is. Very sneaky question for
Yeah.
question 12, I have to say.
So the answer would therefore be that x needs to be between 2 and 3, or x is greater than equal to 6. Yeah, so I missed that second part. Sorry about that. Okay, and yeah, so Jim will be back. You can rub the board out yourself.
Alright, hello everyone, I'm back to solve question number 11. Alright, so question number 11. A. So we have two vectors A and B. Find 2A minus B. So 2A minus B, pretty easy. It's just 2 times 3 to minus -1, 4. Why is my bracket like that? Okay, and then that's just 6, 4 minus 4 plus 1, so it's going to be 7, 0. And then A dot B, well, it's going to be 3, 2, dot -1, 4, so it's -3 plus 8, which is 5. Now part B, solve x squared minus 8x minus 9 less than or equal to 0. We can just factor this, so it's going to be x minus 9, x plus 1 is less than or equal to 0. And by just drawing the graph, right, we have intercepts at 9 and -1. The parabola is going to look something like this. So the region in which the parabola is less than or equal to 0 is this region. So x is between -1 and 9. All right. Number C, using the substitution u equals to x minus 1, find the integral of x square root x minus 1 dx. Alright, so I'm just going to use the substitution, so let u equals to x minus 1, du is going to be dx, so we don't have to worry about replacing anything. Alright, so I'm just going to rearrange this here. X is going to be u plus 1. So we're going to have u plus 1 square root of u, right, because u is x minus 1 dx. Oh, sorry, du. And then that's u to the half. That's u to the 1. So it's going to be u to the 3 on 2. Okay, u to the 3 on 2 plus u to the half du. And we'll just use power rule. So it's going to be 2u to the 5 on 2 over 5 plus 2u to the 3 on 2 over 3 plus c. Alright, part D asks us to solve the differential equation dy on dx. Equals to xy. This is pretty standard equation. Oh yeah, and we have the restriction y greater than 0. So this is going to be important once we have those absolute value signs. We want to sort of get rid of them. Alright, so we just separate this. We place all the y's on one side and integrate with respect to y. And we move all the x's to one side and we integrate with respect to x. So it's going to be x dx. Alright, so that's natural log. And then don't forget, we can't forget the absolute value. And then that's going to be equal to x squared over 2 plus some constant c. Now, since y is going to be strictly greater than 1, and we have to justify this, by the way. So since y is strictly greater than 1, sorry, not 1, y is strictly greater than 0, natural log of y is simply going to be the natural log of y. Sorry, natural log of the absolute value is going to be as if we had no absolute value. So we can just kind of ignore this thing. So that's just natural log of y on its own. And then we can just take the exponential of both sides. We get y equals to e to the x squared over 2 plus c. All right, and then using the properties of exponents, we can separate this into this times that. And then letting this equal to a, we get a e to the x squared over 2 as our solution. All right, let's move on to part E. All right, so we want to differentiate f of x is equal to the sine inverse of x to the 5. So df on dx, just by using the chain rule, it's going to be the derivative of this thing over here at the top. So it's going to be 5 x to the 4 divided by the square root.
By the way, for question 11D, it's a very... Thank you to those who in the chat who said that. Question 11D, there's a quite an interesting point because they want the answer in terms of e to the power of f of x, which means you have to move the a back up into the e, which is actually interesting. So, yeah.
Sorry, what?
You have to move the a up into the e. So just leave it as x squared on 2 plus c.
Yeah,
and I think that's what they're looking for.
That is interesting. Okay. It would suck if I lost the marking exam for that. I'd be very mad. All right, so that's that. Let's continue with this. So we all know the formula for the derivative of sine x. It's just going to be the function inside squared. So it's going to be 5x to the 4 over square root 1 minus x to the 10. So that's our derivative. All right, and then question number F. It's a pretty standard related rates question. So we're given. We just have to interpret the information that we're given. So we have V equals to 4 over 3 pi r cubed. We are given that the volume of the sphere is increasing at a rate of 10 centimeters cubed per second. So the rate at which the volume is increasing is dV over dt, and it's positive, so it's going to be, it's increasing, so it's going to be positive 10 centimeters cubed per second. And we want to find the rate of increase of the radius. So in other words, we want to find dr over dt. So we just want to find a way to manipulate these two fractions, not fractions because they're not fractions, but relate these rates to each other by the chain rule. So it's going to be dr over here, right, over something, times dt over here. Okay, we just have to fill in the gaps. Well, what are we given? We're given v in terms of r, so we could very easily find dr over dv. And then we're also given dv over dt, so it's going to be this. All right, so it's just going to be 10 times dr over dv. Let's find dr over dv. So dv over dr is just 4 pi r squared. And then dr over dv is just the reciprocal. So dr over dv is 1 over 4 pi r squared. All right, so that's 10 times 1 over 4 pi r squared, and then the 4 and the 10 combined to become 5 over 2 pi r squared, as required. Okay. All right. Final long response question. All right, and then we move on to the multiple choice. Okay. So we have some region bounded. I'm just going to draw it. Okay. So we have the line y equals to x. We have pi on 2 over here on the x-axis. We have the function sine, and we're trying to find this area over here. Pretty standard. It's just like a maths advanced question. So it's going to be the area. So the bigger area minus the smaller area. Bigger area is obviously going to be given by the line y equals to x. So this will be the integral from 0 to pi over 2 of the bigger sort of function, x, minus the smaller function, sine x, dx. All right, so you can get x squared over 2 plus cosine x evaluated from 0 to pi on 2. Okay, plugging in pi on 2, we're going to get pi squared over 8. And then cosine of pi 1, 2 is 0. We subtract, and we plug in 0. So putting 0 into the x squared is going to be 0. Cosine, when it starts at 0, it starts at 1. So it's be 1. What do you mean plus 1? Oh yeah, it is plus 1. Okay. And then, yeah. So, wait. Sorry, what? Why is this plus? Oh yeah, it is plus, I'm tripping. Okay, so it's pi squared over 8 minus 1, yes. Because if it wasn't, this would be negative, and that wouldn't make sense.
Yeah.
All right, so that's all of the section 2. Do you have any questions, section 2?
I don't think so. I don't see anything.
Okay. All right. Now Vivian is gonna. Yeah. Now Vivian's gonna come up and do the multiple choice. So I'm just gonna rub the board for her because she's a bit short.
That is untrue, everyone. Yes. I'll just take them. Okay. Wait, I need to scroll this. Okay, so MCQ is pretty simple this year. So first one is just a polynomial, has 3 zeros. So using Vieta's law of theorems, we can do the sum of the roots, -1 plus -3 plus alpha is equal to -2. So alpha is equal to 2. So the answer is B. Another way you can do this is if -1 and -3 are roots, that means x plus 1 and x plus 3 are factors. And for you to get the x cubed plus 2x squared minus 5x minus 6, you want a -6 here, so you need an extra -2 here. And this makes x equals to 2 a root. So the answer is B. Question 2 is asking you to kind of look at this region and these regions and find an expression using integrals to find the area. So firstly, we're trying to find the area, so it needs to be a positive value. So you need to subtract f of x from g of x or vice versa, depending on which curve is on top of the other. So a general kind of gist of it is something like this. So for this region, we can see that g of x is greater than f of x. So we would do g of x minus f of x for this region. And this is the region from -4 to -3. For this region, we can see that f of x is greater than g of x. So we would do f of x minus g of x. When I mean greater than, I mean it's on top of it. And this region is from -3 to -1. This region, again, g of x is on top. So g of x minus f of x. From -1 to 1, and then this region is back to f of x minus g of x from 1 to 4. So the only one that kind of matches up with these 4 separate integrals is obviously not a and b, and the answer is D. Because D, in part C, they kind of just assume it's always f of x minus g of x. So in fact, if you look at C, that expression is the exact same expression as part A. So A and C are the same thing, so the answer is D. For question 3, we have 4 schools, and we want each school to have, at least 20 students from one choir of one of the schools. So how we do this is you kind of just assume, if I get, in the worst case scenario, 19 kids from each school for the choir, there's still no 20, but there's 19 from each school. And this is like the slowest case where we can get the 20 students, right? So we get 19 from each school, and as long as I get one more student, no matter what school this kid is from, it will have to make that school have 20 kids because every school already has a count of 19. And this will get you 77, which is B. For question 4, for question 4, we can see that actually this function is somewhat familiar. We can simplify it into 2 times cos inverse of 2x plus sine inverse of 2x. And a property that we've kind of gone through in year 12 is that cos inverse of theta plus sine inverse of theta is equal to half pi. So it gives you a value, so it's just a constant. So this y is actually just equal to pi. So what we can see is that the range is obviously just going to be pi. So it's either A or C. And then to find the domain, we know that the domain of a cos inverse or sine inverse function is between -1 and 1. So that means we can say 2x must be between -1 and 1. So x is between half and -half. So the answer is A. Okay, moving on to question 5. Not too much to say here. G of x is equal to 2 sine inverse of 3 of x, 3x. So this is in the 2-unit course, so it's just graph transformations. When we have a constant or a number on the outside, this dilates it vertically because it's affecting the entire output. And so it's a 2 there, so we're going to dilate it by a factor of 2 vertically. Means you're going to stretch it this way. And when there's a 3 in the inside, we're going to do the opposite. We're kind of going to compress it by a factor of 3. And compressing by a factor of 3 is essentially the same as dilating by a factor of a third because they're opposites. Oh, shoot. Yeah. Okay. Question 6. For this one, quite simple again. Absolute b is equal to absolute of b sine 4x. We can just cross the b's out because we know b is not 0, so it doesn't affect the equation. So essentially we're trying to solve that sine 4x is equal to plus minus 1 because it's in an absolute. So we just want to solve for sine 4x is equal to plus minus 1 such that x is between 0 and 2 pi. And we should get 8 answers because you can think of it like for sine x is equal to plus minus 1 for this domain, we can get two solutions. So if we have 4x there, you expand your domain by 4 times, and you can fit 4 times of this solutions. So it's 8. Do I need to write the solutions out? Probably not, right?
Sorry.
Is that good?
Yeah.
Okay, great. Question 7. So you do question 8. Yeah. Question 7 is a little bit like what I do in my UK exams. Okay, so you have 5 questions left and you need to get 4 or 5 correct. So for those of you that put B as your answer, you forgot to consider the case that you got all 5 correct. So the first case is you get 4 questions correct. So using binomial probability, you choose 4 of the 5 questions to get correct. There is a 1 in 4 chance you get them correct, so to the power of 4, and a 3 in 4 chance that you get them wrong. And this should get you 15 over 1024. And the case 2 is where you get all 5 correct, so that's just simply 1 over 4 to the power of 5. And if you add these, the sum is equal to 1 on 64, so the answer is C. Yeah.
Alright, hello, I am back to solve questions 8 and 9. Wow, won't even wipe out the board for me. Okay. Alright. So question 8 is a sampling proportion question. Should be pretty easy if we know our formulas. Okay. So local council is proposing to ban dog walking on the beach. It is known that the proportion of households that have a dog is 7 over 2. Alright, so that would be P here. Sorry, 7 over 12. Did I say 7 over 2? Okay, so the local council wishes to poll n households about this proposal. Let P hat be the random variable representing the proportion of households polled that have a dog. Okay. So I'm going to let x be a normal distribution with mean mu and whatever standard deviation. Sorry, it's not going to be normal. Yeah, it is going to be normal, sorry. Actually.
Is there a problem?
I'm trying to I'm trying to figure out which distribution this has. Yeah, this is my own working. I did get the answer, but like, I'm not sure how to set it up here.
Sorry?
What question?
Yeah.
Is there no answer?
No, there was an answer. I looked at it.
There was an answer.
It's a binomial distribution.
It is a binomial, yes.
Yes.
I don't know why I said normal. Alright, so x is going to be binomially distributed with probability NP. Sorry, we put P here, so I'll just put P0. Okay, so it's going to be NP here, and then the proportion is just going to be the x divided by the number of people. So that's the definition. Alright, so we want the standard deviation of P. Okay, so to find the standard deviation, let's just first find the variance. So variance of P is variance of x over n. Okay, and we want this to be less than 0.06. The variance of x over n is 1 over n squared times the variance of x. Okay, so that's just the property of the variance, and it's quite easy to verify that just because variance is defined as the sum of all x squared, x minus mu squared p of x. So it makes sense for this to be squared as well, right? So that's just a fundamental definition of the variance. And we want this to be less than 0.06. The variance of x, the variance of a binomial, is going to be npq, so npq over n squared. And that's going to be pq over n. We want this to be less than 0.06. I feel like I'm missing something here. Right. We want the standard deviation to be less than that. So I'm going to square root everything. Okay, so we want the square root of this to be less than 0.06. And then if we just rearrange for n, it will have to be greater than. So it's going to have to be greater than 277.778 times p, which is 7 over 12, times 1 minus p, which is 1 minus 7 over 12. And then that would have to be greater than 67.51. Okay, so it has to be greater than this, and obviously n, it has to be an integer because you can't have like half a person that you sample. So n, we just have to round this up. We take the ceiling. So n has to be 68, which should be b. Okay, so that's question number 8. Now let's move on to question number 9. It's probably like the hardest multiple choice question, in my opinion. All right, so we have a bag of n metal coins with n greater or equal to 3, either made from silver or bronze. There are k silver coins in the bag and the rest are bronze. So let's just visualize this. We have a bag. We have some silver coins. I'm going to represent the silver coins with x. And then, Right, so Vivian made a joke that this is a magnetic field into the page. That's pretty funny. All right, anyways, and then I'm going to represent the bronze coins as circles. Okay, so that's our visualization. 2 coins are chosen from at random from the bag. The first coin drawn, not being replaced. So there's no replacement here. All right, so we want the probability that 2 coins drawn are made of the same metal. Right. So I'm going to first, instead of thinking about all of this, right? So we have n silver coins, we have n of these, and we have n minus k of these. Right? And this is a bit hard to think about. So what I'm going to do, I'm going to look at like the simplest scenario, which would be when n is 3. So we have, actually n is 4. So we have 4 silver coins. And then let's say we have one. Actually, no. Let's say we have 3 silver and then 2 bronze. Right? And then, so by considering this simpler example, we'll eventually arrive at the solution. It's the exact same. All right, so we want the 2 coins to be of the same color. Right? So since each coin is equally as likely, we can just count the number of favorable outcomes divided by the total number of outcomes. So let's find the total number of outcomes that are favorable. So we can either have 2 silvers 2 bronze. Okay, so the number of ways to get 2 silvers is the first, you have 3 silvers to choose from. After you've chosen the first silver, you have 3 minus 1 silvers. Same with bronze. At first, when you put your hand to the bag, there's 2 bronze, so you can choose from 2 bronze. And then after you've already chosen one, that's going to be gone, so you have 2 minus 1 left to choose from. And then the total number of ways to choose 2 coins will just be, well, we'll choose 1 N coin. Oh, sorry, here it will be 5. Right, we have 5 total coins, and then we have 4 left over. So it's 5 minus 1. So this is the total. This is the favorable. And notice how this is literally like the answer. We're done here. All we have to do is replace the silver with K. Right? Let's generalize this because this is true for all scenarios. We have K silver coins. We have N minus K bronze coins, because they have to add up to N. Here, instead of 3, it's going to be K. We have K minus 1. And for the bronze, we have N minus K. N minus K minus 1. And in total, we just have N. And then N minus 1. And then now all we have to do is divide the number of favorable outcomes over the total outcomes. So therefore, probability of the same will be K minus 1 plus. So note the or here, that just means plus. There's separate disjoint cases, so we add the probabilities. So K, N minus K minus 1 over N times N minus 1, which would be A. All right, now Vivian's going to come up and solve the... Sorry, what? Am I doing 10 as well? Okay. Did no one solve 10 yet?
We've done it.
Yeah.
Do you want to do it or us do it?
Okay, well, we can do it together.
You can stay there and we'll do it together.
Okay.
Great.
All right, so question number 10.
Hello.
Alright, for real numbers A and B, where A is not 0, B is not 0, we can find numbers alpha, beta, gamma, delta, and R such that A cosine bx goes A cosine x plus B sine x is equal to blah, 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 where R is greater than 0, etc., etc. What is the value of alpha plus beta plus gamma plus delta?
We can just equate the first 2 signs and the second 2 causes to each other to find a relationship between alpha and beta.
Sorry, what? I think you should come up and explain.
No. So,
What are you talking about?
so the 4 terms must be equal to each other, right?
Right, so
So R sine x plus alpha is equal to R sine x minus beta.
Right.
Yeah, we know alpha is not equal to negative beta. Oh yeah, you can write the other one down first.
They would all be equivalent, yeah?
Yeah.
It's a 4-way inequality, yeah.
Yeah, but I think you can just split it into the causes and the sines. Yeah.
And we expand?
We don't have to expand. So you know that, okay, looking at the first line, we know that in one case, alpha is just equal to negative beta, right? And
Speak into the mic.
I am,
Okay.
right? Like you can just say alpha is equal to negative beta, but obviously we know that nothing is negative. They're all positive angles. So that can't be true. So they must be different by a 2 pi. So alpha must equal to 2 pi minus beta for these 2 signs to be equal.
Yeah.
And similarly for the next one as well. Oh, yeah.
Alright, so adding them up.
And then you're done.
Okay, so
And also, if you
Just hold my
substitute
hands out.
your angles, so like if you look at the sign, if you substitute alpha equals 2 pi minus beta into one of the signs, you will get the other one. Or to be specific, you'll get x minus beta plus 2 pi. And since sine is 2 pi periodic, you know that works. You can do the same thing for the cos, just to verify your answer and be, confident in what you've put down.
Okay.
Yes, sir.
All right, that's the whole paper. Does anyone have any questions?
Woohoo!
No questions?
Oh.
We all good?
One quick thing. Somebody asked if we're going to provide written solutions. This was like a while earlier on. Just wanted to say, since it's at the very end, that we are going to write up solutions to this, and it will be posted. So stay posted.
Hope everyone did great today.
All right, come on.
Too
guys.
late to say that. Oh yeah, so if you guys have missed any of the questions or you came late, you can just re-watch the YouTube video. It will probably stay up there for, I'm assuming 24 hours, but hopefully longer. And yeah.
All right, great. Remember, what's it called? Year 10 Maths, Strathfield, Tuesday, 4th.
Year 11, 2-unit maths.
Tell your brothers
Year
and
11,
sisters.
2-unit maths,
Tell your brothers and
Strathfield,
sisters.
Saturday.
Thank you
Tell
very
your
much.
sisters and brothers to come. Huh? Oh, and there's a discount for this term, so if you join now, you get a discount. And there's a 2-week trial. It's free for existing students. $80 for any of you that are not existing students. And yeah, is that it? So join. Yeah.
A lot of people are saying it's 2 pi.
It's what?
A lot of people are saying the answer is 2 pi to question 10.
We're cooked.
We'll have a look at it later.
We'll.
No,
I feel like we
they're
have
just-
to address it now.
Okay.
Wait, is it 2 pi?
So apparently,
I know, I feel like your working out was fine, but I don't get why it was not 2 pi.
Okay. What do we do?
could be,
I was gonna say it's 3 pi, but it's not.
could be 3 pi.
No, that's not even one of the options.
Sine of x is.
Yeah, that's what I'm saying. Sine of x is pi minus.
Yeah?
So why can't it be 3
Oh,
pi?
I tried that out and it doesn't work.
Okay, yeah. No, my initial thought it was 3 pi, but it was not that.
Interesting.
Well, for those of you who are wondering, who assert that it's 2 pi, would you mind providing a reasoning for why you think it's 2 pi? We can have a look at it now.
Yeah.
It's a good time.
Yeah. So if you guys didn't hear that, could someone give us their thought? Yikes. Oh, very weight on top. Bio. That was a violation. The angles will be acute, right? So if we add them up, we would just get back to the origin, a 2 pi rotation.
Not necessarily.
I don't think they have to be cute, yeah.
Yeah, the angles range.
They
from
don't have
0
to be acute. When we use the R method, you can let your range be from 0 to 2 pi instead. Because if you don't let it be 0 to 2 pi, then you can't have that transition from x plus alpha to x minus beta. Right?
Yeah, we try to do it more definitively.
Okay, I'll take a look at the chat while you guys figure it out. Someone said to construct expressions for each variable and then sum in terms of A and B. And they said no, but the relative angle will never be obtuse. The relative angle as in the smallest one. A and B are positive, right? No, A and B are not. We don't know. A and B can be anything. So it can be an obtuse angle. Yeah, someone says they just plugged in cos of x plus alpha is equal to cos of x minus bracket 360 minus alpha, which is what we did. Right. Oh my god, someone said something.
Okay, yeah.
Wait, hold the phone.
Yeah, they're equal to alpha plus beta is 2 pi. Yeah, still takes 2 pi.
Wait, is the YouTube video this? Wait,
What?
is it just his? Oh, his thing is cut, right?
What's cut? Oh.
Yeah. Okay, wait. It's just his laptop. Okay, good.
Wait. If you go full screen, I think.
Yeah. I was scared that the whole time that was cut off. Never mind. Okay, we gotta figure it out, guys. This is the mark that determines the state rank.
You just check what I've done.
Sine alpha is negative sine beta.
Yep.
So it's not a 2 pi. It's pi. We're cooked. We're cooked.
Sorry.
Pi.
Really?
Right?
What we're looking
Sine sine alpha is negative sine beta. So this means that beta
What?
Well, I mean, if they're negative.
oh, that just means alpha is equal to negative beta, or alpha is equal to 2 pi minus. Oh wait, you're right. Never mind. You're right. Never mind.
Yeah, alpha equals.
Never mind. You're right. We're right. We're right. Alpha is equal to 2 pi minus beta. Yeah. So the reason why we cannot take alpha is equal to pi plus beta is because we need to find alpha plus beta. This would only get us what alpha minus beta is. So that's not what we want. We want what alpha plus beta is. Right.
Yeah, I think so.
Okay.
Yeah, same thing here.
Yeah. So okay. I'm convinced it's 4 pi. What do people have to say? The guy on the board is doing it the right way. Doing the way I did. Someone says.
Okay.
That guy on the board is called Kevin.
Yeah, that makes logical sense. It should add to 4, right?
Okay, we're done.
Yeah, I think that's good.
I'm glad the exams were easy for you guys. Okay, what do we do now?
Let's just finish it off.
Okay.
We'll solve the questions. Yeah, finish it with that. Alright.
Bye guys. Come and say bye.
Yeah.
Yeah. Bye guys.